Welcome back, everyone. In this lecture, we're going to discuss if, elif, and else statements. So as I mentioned, in this lecture, we're going to discuss control flow in general. And control flow basically allows us to use logic to execute code only when we want to. So often you have a larger piece of code and you only want certain code to be executed when a particular condition has been met. For example, let's imagine that I'm trying to program a robot to feed my dogs. Then I could say if my dog is hungry, so that's the condition, my dog being hungry, then I'll have the robot feed the dog. It'll have the actual code execute or perform some action. So in order to control this flow of logic, we use some keywords. And the keywords we're going to be introducing in this lecture are if, elif, and else. So let's see the syntax for these three keywords. In order to understand the syntax, we have to understand that control flow syntax in Python makes use of colons and indentation, otherwise known as whitespace. And this indentation system is absolutely crucial to Python, and it's really what sets it apart from other programming language. This use of whitespace and indentation allows Python code to be easily readable and very quick to prototype. So here's the syntax of a basic if statement. We're going to say if, so that's a keyword, some condition. So some condition is usually some sort of comparison operation that we just saw in the previous section of the course. So that could be something like if hungry is equal to true, colon, and then notice that that blue line is indented further than the if statement. So that says anything along that indentation is going to be executed if that condition happens to be true. Now, on top of an if statement, we can add an else to this. So let's say that condition doesn't happen to be true, we can have another block of code execute. So in this logic, we say if some condition happens to be true, we execute some code. Else, meaning that condition didn't have to be true, we do something else. And notice how the else doesn't have a condition attached to it. It only actually executes if the conditions above didn't happen to be true. You should also notice that the if and else, indentation-wise, are lined up with each other. If you want to check for multiple conditions before that else statement executes, you can have an elif statement or elif statement. And basically you say if some condition executes some code, elif some other condition do something different, and you can have as many of these elifs as you want, and then finally all the way at the end you can have an else statement to do something else. Okay, let's explore all these concepts by actually coding out some examples in a Jupyter Notebook. To begin all of this, we're going to start with the simplest example we can do, which is a single line of an if statement with just a Boolean condition. We're saying if true, colon, and note what happens when I hit enter. I have this indentation automatically done for me. And if you're using any text editor and you have defined the file as a .py script already, you should see this indentation occur automatically for you as well. Then we're going to say print, it's true. So then I'm going to run this, and we see if true, print it's true. So notice we're saying if some condition is true, print it's true. Now typically you won't have just a Boolean like this, otherwise you'll always be printing that. Instead what you may have is something like a comparison operation. So we'll say if 3 is greater than 2, print it's true. We run that and we get back it's true. And then to make this even more realistic, we'll say hungry, set a variable there, we'll say hungry is equal to true, and then I will say if hungry, print feed me. And if we run that, we see that we get feed me. We can also then set hungry to false, and now if I run this code again, notice I don't get back anything else. So I have some condition, and it happened to be false, meaning this block of code didn't execute. What I could do is add in an else statement to execute if this condition doesn't happen to be true. So we hit enter again, and then we hit backspace in order to line up our else block with that if statement. So if we want this else to be lined up with this if, they need to be at the same indentation in our code. And a lot of times when you're working with any text editor, it'll kind of automatically line things up for you, so keep that in mind. So else doesn't have any other conditions attached to it because we're only going to execute else if none of the conditions above happen to be true. So right now we're saying if you're hungry, print feed me. Otherwise, print I'm not hungry. I'll run this, and right now because hungry was equal to false, we're getting back I'm not hungry. If we change hungry to be true, we get back feed me. What's also important to notice is that I'm just passing right here hungry by itself as a Boolean. I don't actually need to do something like this, check that hungry is equal to true, because hungry by itself is already a Boolean. And we'll explore that example later on in more detail. So if hungry prints feed me, else prints I'm not hungry. Okay, now let's discuss multiple branches using if, elif, and else. So let's look at another example. I'm going to say LOC, which stands for location, and I'm going to set that equal to bank. So I have a location, it's equal to bank, and I'm going to say if my location is equal to an auto shop, I will print cars are cool. Else, I'll print I do not know much. So when I run this, it says I do not know much because the location was bank, and we have location equal to auto shop, print cars are cool, so that didn't execute. So then we have else printing I do not know much. What we can do is check for other conditions using elif. So let's pass in another condition here. We'll say elif, the location, is equal to the bank, then print money is cool, as I'm sure everyone at the bank says. And then we run this, and we get back money is cool. So here we can stack on as many conditions using an elif statement. So we can add in more elifs for more conditions. We can say LOC is equal to store, colon, print, welcome to the store. We run that and we still get back money is cool, but as soon as we start changing this condition, let's change it to auto shop. We run that, we get back cars are cool. If we change it to store, we get back welcome to the store. And if we change it to something else that's not in any of these conditions, then we'll have the else block code execute. So let's see what that looks like. Let's say we're going to some game, and it says, I do not know much. Perfect. All right, just to drive this point home of indentation and whitespace, we're going to do one last very simple example, pretty much exactly the same as the last one. Let's define a name. We'll say Sammy, and we'll say if this person's name is equal to, let's say Frankie, we'll print out hello Frankie. Then we'll say elif, we have some other name. If elif name is equal to Sammy, print out hello Sammy. And then typically for your else condition, it's going to be something where none of the other conditions were met. So a good thing to do here would be ask the person what their name is. What is your name? And later on in another lecture, we'll actually learn how to get input from the user. But for right now, let's focus on a couple things here. Note the indentation, and note how if, elif, and else are all lined up with each other, and their respective blocks are all indented. And then we also have this colon at the end of these conditions. So now when I run this, we should expect to see hello Sammy. And if I were to change this to Frankie and run it again, I get back hello Frankie. And if I change this to a name that's not there, like Jose, I get back what is your name? All right, that's the basics of if, elif, and else. They seem pretty simple, and hopefully they were pretty straightforward to you. Later on, we're going to use them to create really nice large pieces of code that can execute more complex tasks. We'll see you at the next lecture. Welcome back, everyone. In this lecture, we're going to discuss for loops. Now, many objects in Python are iterable, meaning that we can iterate over every element in the object, such as every element in a list or every character in a string. And we can use for loops to execute a block of code for every iteration. So I want to focus a little bit on this term iterable because you hear it a lot, especially in Python documentation, and it's kind of a strange term if you've never heard it before. So all this term means is that you can iterate over the object, and that means you can perform an action for every thing in that object. So for example, for every character in a string, you can iterate through that string and then do something for every character. Often maybe you want to print out every single letter in that string or every single character in that string. So that means the string is an iterable object. You can work through it. You can also iterate over every item in a list. That means the list is iterable. And then you can iterate over every key in a dictionary. So the dictionary itself can also be iterated over. So kind of a little funny term there, but just think of it as a way of going through something. So let's go over the example of the syntax of a for loop. So this is the syntax of a for loop right here. Notice that we have a list defined, and then we have a couple of keywords, and then we're performing some actions. So let's focus on each aspect of this syntax. We start off with this statement, and this is just an assignment. We're saying my iterable, we're choosing that as a variable name. This could be my list, my items, my dogs, whatever you want, is equal to, and in this case, we're choosing a list. We're going to see other examples of other iterables in just a second. So we make some sort of assignment. We have a variable name there. And then we're going to say for, so that keyword for, item name. So this is a variable name that you can choose that's going to be a bit of a placeholder for every single item in your iterable object. So in this case, the item name actually represents the numbers in that list. Then we say in, so another keyword there, and then the variable name that you chose, in this case, my iterable. So we're saying for every item or item name in this list of 1, 2, 3, then we have a colon, and then we have some white space, and then we perform or execute some block of code. In this case, we're saying print item name. But you didn't have to actually use the item name. You could have just printed hello 3 times. So we're going to show more examples of that. But that's the basic syntax for a for loop. So let's actually explore these concepts in a Jupyter notebook and try to build a deeper understanding. So we're going to perform for loops for a bunch of different objects in Python. And I think by the end of this lecture, you're going to have a fair understanding of the basic idea of for loop and how to work with them. And this is really where you begin to level up your skills. So before, we've basically just been learning about data types, objects. We haven't really been able to construct anything yet. Once you start learning about control flow and for loops, and later on while loops, and then after that functions, etc., this is where we really start to be able to construct logical programs. Okay, so it's an exciting leap. Let's head to the Jupyter Notebook and get started. All right, let's begin with a simple example. I'm going to create a list called myList, and we're going to set this equal through the numbers 1 through 10. We'll say 1, 2, 3, 4, 5, 6, 7, 8, 9, and then finally 10. And as a very quick note, you should not use list as a variable name here. Notice that it's being highlighted through syntax highlighting. That means list is a built-in keyword, so avoid using just list by itself as a variable name. If for some reason you accidentally already did that, go ahead and delete this, and then just hit kernel, restart, and then restart this, and that will reset all your variable names. What you will need to do is then rerun some cells if you already have stuff defined. So I just need to rerun that. Notice how now it's back at 1, so I've restarted everything. Okay, so I have this list 1 through 10. Now I'm going to create a for loop to iterate for every item in this list. So I start with the keyword for, and then I get to choose a variable name that's going to represent the elements inside of this list. So we're going to say for num in my list, that iterable, colon, I hit enter, and notice now how I have an indented block of code there. So now I can interact with those actual elements. So let's print them out. I'm going to say for num in my list, print num. And then when I run this, I see 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's actually printing out this number for every number in that list. Something I want to make really clear though is that this particular variable name that you chose to represent the elements inside that list, it can be whatever you want. So here I chose num because these are numbers, but I'm going to just make it really obvious by choosing jelly and then saying for jelly in my list, print jelly. Run that again and you get back the exact same results. So again, this variable name can be whatever you want. This iterable can't be, it has to be predefined, but this variable name that's going to represent the actual objects inside that iterable, that is whatever you want. Now I also want to show you the point that we technically don't even need to use this variable name. We can still execute some block of code for every single item in this list, even if the code itself is unrelated to the item. So I can print hello for every item in that list, and we get back hello 1 through 10 times. And again, we can call this whatever we want. Num, run that, and we get back hello 10 times. So keep in mind, when choosing these variable names, you have full flexibility, so you'll want to choose a variable name that is somehow related to the object inside that iterable. Now let's combine our knowledge of for loops with a little bit of what we just discussed in control flow. Let's see if we can print out only the even numbers in this list. So to do that, what we're going to do is start off by saying for num in my list. And then I'm going to add in some control flow to somehow check if the number is even. So I'll say check for even here. This is just a comment. And then what I will do is the following. I'll say if num mod 2 is equal to 0, colon, print the number. So what I'm doing here is I'm saying, okay, for every number in that list, if the num mod 2, so remember that's the remainder when you divide by 2, is equal to 0. So if there's an even number and you divide it by 2 and the remainder is 0, then you can go ahead and print that number. So then when we run this, here we have all the even numbers, 2, 4, 6, 8, 10. And I can add even more control flow by attaching an else statement to this if statement, and then say print odd number. And we can even do some f-string literal formatting, so I can say if odd number, right there, run that, and it says odd number 1, 2, odd number 3, 4, odd number 5, 6. So this is some good work here as far as combining for loops with the control flow from before. Key things to note here is the indentation. So luckily Python is very clean because of the use case of indentation. So everything at this indentation level is inside of this for loop. So this entire block of code is going to execute for every single number in that list. And then we can see that this print num is only going to execute when this if statement is true. And this else indentation is lined up with this if. So we say if, this case, print num, else, and then we print out the odd number. And again, using some f-string literal here to nicely print out that number itself. All right, let's move along. So another common idea for a for loop is to keep some sort of running tally during multiple loops. And later on, we're going to show you the enumerate function, which kind of does this for you automatically. But for right now, what I'm going to do is say list sum is equal to 0. So let's try to get the sum of every number in that list. So I will say for num in my list, I will say the list sum is equal to the current list sum plus the number. And then I'm going to, outside of this for loop, print out the list sum. So when I run this, I get back 55. So this is a good example of indentation and a use case. So right now I have this list sum. So I'm saying my initial sum is 0. Then for every single number in that list, I take my old value for my sum and I add on the current number, and then I reassign that value to list sum. So I do that over and over again for every number in that list. And then at the end of this for loop, once it's done completing, so notice the indentation level here, I print out list sum. Let's see what would happen if I were to press tab here and have this print statement inside of this for loop. Now when I run this, I get back kind of the running tally of this sum. So it starts off at 0, and then once it has this first run inside of the for loop, it gets printed out. So then it has 0 plus 1, well that's equal to 1, so it prints out 1. Then we have 1 plus 2, well that's 3, then it prints out 3. 3 plus 3 is 6, 6 plus 4 is 10, 10 plus 5 is 15, and so on. So now we get the running tally, and it's only until the very end that we see 55. If we only want to see the last result, then I just have this print outside of that for loop. So that's why indentation and white space is so important. So we just saw how to use for loops with lists, but what about strings? Remember, strings are a sequence, so that means we can iterate through them, and we'll be accessing each character in that string. So we'll say for letter in, and let's create a string. We'll say my string is equal to hello world, then for letter in my string, colon, print out that letter. And I run this here, I can see HELLO space WORLD. So that's the way we can actually iterate through a string itself. And technically, you don't need to actually assign a variable name to the string. What you could do is just straight up put the string here. So we could say for letter in hello world, print letter. And we get back the exact same results. And I really want to drive this point home. You can call this whatever you want. So this letter variable name, you can say GHGH, and as long as it's the same thing inside of this, and you run this, you'll get back the same result. And the other thing I want to stress is that you technically don't even need to use this variable. So a lot of times what people do as they get more advanced in Python, for some reason they want to iterate something a certain amount of times. So imagine I wanted to print cool for as many times as there are characters here. So I see cool, 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 cool. What they do is instead of assigning this variable name, they just use an underscore. And that's really common syntax for when you don't intend to actually use that variable name as you iterate through. So they just use a simple underscore there. That way it's a little more readable. Okay, so that's iterating through a for loop. You can also use the same iteration for a tuple. So I can say tup is equal to 1, 2, 3. Then for item and tup, print out the item, run that, and I get back 1, 2, 3. Now, I want to mention tuple unpacking. So tuples have a little bit of a special quality when it comes to for loops. So if you're iterating through a sequence that contains itself tuples, the item can be used with tuple unpacking. So let me show you what I mean by this. I'm going to create a new list called myList, and I'm going to set this equal to a list of tuples. So here I have square brackets, and I'm going to make some tuple pairs. We'll say 1, 2, comma, then 3, 4, comma, 5, 6, comma, 7, 8. So notice what I have here. I have a list, and then there's tuple pairs as items in that list. So if I check out the length of my list, I have 4 items in it, where every single item is a tuple pair. So let's print out those items themselves. So for item in my list, print out the item. And when I run this, I actually see the tuples themselves. 1, 2, 3, 4, 5, 6, 7, 8. This sort of data structure is extremely common in Python. And later on, we're going to see that a lot of built-in Python functions actually take advantage of this built-in structure and return back tuples inside of a list. And the reason for that is something called tuple unpacking. Right now, we had to print out every single item inside this tuple. But what I could do is the following. I could say, let me delete this print statement. I could do the following. I could say for, and make kind of a temporary variable name that looks like a tuple here. So for AB in my list, then I can print the variable A, and then print the variable B. So note what happens now. I'm saying 1, 2, 3, 4, 5, 6, 7, 8. So what's actually going on here? Well, this is called tuple unpacking, where you kind of duplicate the structure of the items, in this case tuples, inside of this sequence, and then unpack them. So now I have access to the individual items. So if I only want to print out the first item in those tuples, so I run this, I get back 1, 3, 5, 7 because now I'm only printing A. So this is known as tuple unpacking, and technically you actually don't need these parentheses here, so it's a lot more common to see it done this way with no parentheses. So now I say for AB in my list, print A. Let's see what happens if we print B. We should get back all those even numbers. So that second half, that 2, 4, 6, 8. So again, this is tuple unpacking. And you're going to be using it a lot as you start working with more built-in Python functions, because a lot of things will return kind of pairs and sequences in this manner, where you have a list of tuples. And I want to show you one more example. Let's say my list is equal to a list 1, 2, 3, 1, 2, 3. Well, let's make it some different numbers. Say 5, 6, 7, and we'll do one more with 8, 9, and 10. I skipped the number 4 here, but no big deal. We'll say for item in my list, print item, and there are my 3 tuples, but I can do tuple unpacking here. So the way I can do that is make up 3 variable names, separate them by commas. So I can say A, B, C. Notice I don't have to use parentheses, and then I can print out whichever one of these I want. For example, if I just want to print out 2, 6, and 9, those middle numbers, I would just say B, and there we go. We have access to B, so just the middle number. So this is really useful when you maybe wanted to reorganize these structures into some other manner, or maybe you only want to deal with the first item in these tuple pairs. Okay, so that's tuple unpacking, and now let's finish off this discussion about for loops by discussing how to iterate through a dictionary. So to do that, we're going to create a dictionary called D. It's going to have K1 as a key value, and we'll have the number 1 as that value. We'll say K2 here, colon 2, and then we'll say K3, colon 3. and then I'm going to, for item in D, print the item. So this is something that's kind of interesting. Notice that by default, when you iterate through a dictionary, you only iterate through the keys. So K1, K2, and K3. If you actually want to iterate through the items themselves, what you need to do is call .items here. And now when you run that, you get back these tuple pairs, K1 with 1, K2 with 2, K3 with 3, which means we can use the same tuple unpacking technique we just discussed. So instead of item, what I can do is say key, comma value, and let's say I only wanted to print out the values. Then I could say for key value in D.items, print out the value, and now I have 1, 2, and 3. Again, taking advantage of tuple unpacking here, because D.items returns back something in this sort of format. And more likely it's this sort of format. We have a key and a value. So we're using the same tuple unpacking that we just discussed, now with D.items. So by default, when you iterate through a dictionary, it's going to be the keys. If you want to iterate through the items, you can use tuple unpacking to grab both keys and values. If you only want the values themselves, what you could do is say D dot, and then call values off of this, run that, and it'll only print out the values 1, 2, 3. The last thing I want to note here is that dictionaries are technically unordered. This is a very small dictionary, so it looks like everything's going in order, 1, 2, 3, K1, K2, K3. But if you have a very large dictionary, there's no guarantee that things are going to be sorted or in any sort of order. So keep that in mind. When you iterate through a dictionary, there's no guarantee that you're going to get things back in the order you put them in. Okay, so now we've learned about how to use for loops with tuples, lists, strings, and dictionaries. This is going to be a really important tool for us, so make sure you understood it well with the above examples. Specifically, make sure you really understand the white space. So probably the most important thing to get out of this lecture is the fact to use this for keyword, any temporary variable you want, you say then the keyword in, some sort of iterable object, either values, the list, or a string itself, as we saw up here, colon, and then in this indented block of code, that's going to execute every single time for every single iterable in that list. Thanks everyone, and if you have any questions, feel free to post them to the Q&A forums. I'll see you at the next lecture. Welcome back everyone. Let's now take some time to talk about while loops. While loops will continue to execute a block of code while some condition remains true. So for example, if we try to relate this to a sort of real life scenario, while my pool is not full, maybe I want my program to keep filling my pool with water. Or if I'm designing a robot with some code, while my dogs are still hungry, keep feeding my dogs. So let's explore the syntax of a while loop. It's actually quite simple. We're going to say while, and then some sort of Boolean condition. So we'll usually have some sort of comparison operation check, and a lot of times it's going to be while some variable is true, or is equals true, then colon, and then a block of code. And that block of code, in this case represented by do something, is going to continue to execute while the condition is true. Now we can also combine a with statement with an else statement if we want. So I can say while some Boolean condition is true, do something else, meaning once that condition is no longer true, or since the beginning it was no longer true, we do something different. Let's explore these concepts with some examples. Let's hop to a Jupyter Notebook. Alright, so let's start off by building out a very basic while loop. I'm going to create a variable, say x is equal to 0, and then say while x is less than, let's actually say less than 5, so we don't have a whole lot of printing. We're going to print the current value of x. So we'll say print the current value of x. Lots of different ways we can do this. We'll just do it quickly with an f-string literal. The current value of x is, and then inside curly braces we'll pass an x. Now let's imagine what's going to happen here. Don't run this cell yet. We'll say x is equal to 0. While x is less than 5, I'm going to print out the current value of x. So if I were just to run this, basically I would say the current value of x is 0. And that would happen over and over and over again because x isn't changing. So let's update x during this while loop. We'll say x is equal to x plus 1. So now let's run this and see what happens. I get back the current value of x is 0, then 1, then 2, then 3, then 4. And on that last one, when it's equal to 4, we then say, okay, x is going to be equal to 4 plus 1, which makes x equal to 5, and 5 is not less than 5, it's equal to it. So then the while loop stops running because it's only going to run while this condition is true. Now, if you accidentally have some sort of condition that never becomes false. Maybe you forgot this last line of code here and it just ran over and over and over again. So what happens is you get an infinite while loop, and it's a common mistake for beginners to make. I know I've made it myself a bunch of times when I was learning Python. What happens in the Jupyter Notebook is you get a little star here indicating that the cell is still continually running. In order to kind of reset things, just come over here to kernel and either hit interrupt, and if that doesn't work, then hit restart and restart your kernel. Sometimes interrupt won't work because basically the command to interrupt won't get there because Python's using all your computing to kind of continue this while loop. So keep that in mind. If you ever get an infinite while loop, just come over here to kernel and then hit restart, and you'll have to redefine some cells again, but that's the basics of avoiding that error. Okay, so we have the while loop by itself, and as a quick note, this statement of x is equal to x plus 1, we can also write that in the following manner. We can say x plus equals 1. So this line and this line are the same thing. This is just a more compact way of writing it. So if you're ever reading someone else's code and they wrote this instead, that's kind of a sleeker way of writing that same code. Let me run this again. We can say now n2, and we get back the same values. Let's attach an else statement to this while loop. So we can say else colon, and I'm going to print x is not less than 5. And now when we run this, let's see what happens. We get the current values, so all those other print statements, and then I see x is not less than 5. So once this while condition is not true, because this else is lined up with it, we went ahead and printed x is not less than 5. Now as a quick note, if right off the bat x was greater than 5, so let's make x is equal to 50, and I run this, then this while loop never executes because this condition is never true, and then we have the else condition execute anyways. That doesn't mean I need it. So if I didn't have that there and I ran this, just nothing would happen because this isn't true. All right, finally, I want to introduce 3 keywords that are really useful with loops. You're not going to be using them all the time, but sometimes you'll need their use cases. And that's the break keyword, the continue keyword, and the pass keyword. Break is going to break out of the current closest enclosing loop. Continue goes to the top of the closest enclosing loop, and then pass does nothing at all. So let's start a little bit backwards here. Let's go with pass, and we can show this actually with a for loop. It might be a little simpler here. We're going to say for, let's make a quick list. We'll say x is equal to 1, 2, 3, and then say for item in x colon, and let's say we didn't quite know yet what we wanted to do here. We essentially want some filler. If I just have a comment here, and I try running this, so when you attempt to run this, you actually get an error. It says syntax error, unexpected, end of file while parsing. And what that means is Python, because it uses indentation and white space as a crucial part of its code, it expects you to basically have something here. Even a comment isn't enough to fill it. So often what you can do is have the pass keyword, and the pass just says do nothing at all. And a lot of times programmers keep it as a placeholder to kind of avoid a syntax error. Because you can imagine if I'm writing a larger piece of code and I know eventually I want to come up and fill out this for loop, but right now I don't want to deal with it. Let's say I wanted to print end of my script over here. Now when I run this, I don't get that syntax error and I'm still able to print out my script. If I just have the comment, I get an error because it's expecting something to happen after this colon. So in order to avoid that, you can use the pass keyword, and you're going to see the pass keyword used a lot when we start building out functions and methods ourselves, because often when you're programming, you'll create a little holder for a function, but you don't want to test it right away. So you use the pass keyword as something to put in place there, so you avoid syntax errors, and you're also safe because you know pass doesn't do anything. It just says, well, I'll pass this, and I'm not going to do anything. All right, so that's the pass keyword, it does nothing at all. Continue goes to the top of the closest enclosing loop. So let's show you an example of that. And we'll actually use for loops again for this. We're going to say my string is equal to Sammy. So let's have that there. And we'll say for letter in my string, print out the letter. So here we see Sammy printed out. Now what I'm going to do is let's imagine that I actually didn't want to print the letter A for whatever reason. I could do the following. If the letter is equal to lowercase a colon, continue. And now when I run this, I'm not actually printing out the letter A. So what's happening here? Well, continue basically tells this program to go back to the top of the closest enclosing loop. So here's continue, and we have a loop up here for letter in my string. So if that letter is equal to A, we continue, meaning go back to the top of the closest enclosing loop. Note that we are specifically saying loop, we're not saying some sort of statement here. So that's where semantics can come into play, but what this is saying is if the letter is A, go ahead and continue and go back to the loop. So that's how you can use the continue statement. If you're a beginner in Python programming, it's definitely not something that comes up a lot in your beginning code. It's going to happen that more naturally you'll start using it much later on. So be aware of it, but don't worry about use cases right now. You won't really be using it that often. And then finally, break breaks out of the current closest enclosing loop. So let's see what happens if we replace continue here with break instead. Now when we run this, what happens is instead of going back to the top of the closest enclosing loop, it breaks out of the current closest enclosing loop, meaning it just breaks this loop and stops this loop if that letter is equal to A. So that's actually really useful, especially with while statements. So let's see an example of using break with a while statement. Let me zoom in here just so we can see this clearly. I'm going to do the same thing as before. We'll say x is equal to 5, and then we'll say while, actually let's make it equal to 0 here, just as we did before. While x is less than 5, print out x, and then we'll say x is equal to x plus 1. So when we run that, as expected, I get 0, 1, 2, 3, 4. But let's imagine I wanted to break this while loop if x was ever 2. Then I could do the same thing here. I say if x is equal to 2, at any moment, go ahead and break out of this while loop. Now when we run this, we only get back 0 and 1. Okay, so that's the basics of this break, continue, and pass keyword. So what we covered in this lecture was the while loop. So while some condition is true, execute this block of code. Be careful here because if you accidentally say while and this condition is constantly true, you may have to restart your kernel. If you're running a Python script and you end up getting that error that the while loop is just never closing, you should try Control-C. That typically interrupts. So you can even see here, interrupt, it says Control-C to go to the kernel. All right, then we have the break, continue, and pass keywords. Again, not going to be using these right off the bat, especially things like continue, but we'll probably be using break a little more, and then once we get used to functions, we'll be using pass a little more, and then much later on we'll be using continue. But you should be aware of these keywords now that you understand both for loops and while loops. Okay, thanks everyone, and I'll see you at the next lecture. Welcome back everyone. In this lecture, we're going to discuss a few built-in functions and operator keywords in Python that didn't really fit well into any of the previous categories. However, they're still really important and they're going to really enhance your ability to program with Python. Let's open up a Jupyter Notebook and quickly run through these. Let's begin by talking about the range function in Python. Notice that often we were creating lists that were just a series of integers, such as 1, 2, 3, or 1, 2, 3, 4, 5, etc., all the way up to 10. Because this is such a common task, Python actually has a built-in operator for this, and there's two ways you can use it. One is you can iterate through it, so I can say something like for num in, and then we use the keyword range, and it takes a couple of parameters. You can do Shift-Tab here to see the parameters it takes, but basically it has a start, stop, and optional step size. So start is technically also optional. Let's show you how we can actually use these. So if we just indicate a single number, such as 10, and we say print num in range 10, what it's going to do is it's going to generate the numbers from 0 all the way up to, but not including 10. So that all the way up to, but not including, that's very similar to that slicing syntax we saw earlier in the course. So for num in range to 10, print number, and here we see 0 through 9. Now let's say we wanted to actually specify a starting index position for the integers. We could say start at 3, go all the way up to, but not including 10. And then when we run this, we get 3, and then all the way up to, but not including 10. So that's the range operator. And in addition to all this, we can actually have a step size as well. So we can add a third argument for step size, and that gives us the even numbers. So that's taking jumps in steps of 2 from 0 all the way up to, but not including 10. So if we wanted to include 10 as one of those numbers, we'd have to put in 11 there, and then we get back 0, 2, 4, 6, 8, 10. So that's how you can use the range function for iteration. But you'll notice if I copy and paste this into a cell and ask for it to be returned to me, I just get back this range operator. And it's because it's a generator. So if I actually want the actual list of numbers, what I can do is cast it to a list, and then I get back the list of numbers. Later on in the course, we're going to discuss generators in a lot more detail, but basically a generator is just a special type of function that will generate information instead of saving it all to memory. So this is a more efficient way of generating these numbers instead of having a giant list stored in memory. And we'll discuss that in a lot more detail in the generators section of the course. Let's move on to discussing another really useful function called enumerate. And to show you the use case and motivation behind enumerate, let's do an example. I'm going to set a variable called index count equal to 0. Let me zoom in here one level. So I have index count is equal to 0, and then for letter in the string A, B, C, D, E, I'm going to do some printing here. I'm going to say at index, the letter is curly braces. And then I will use dot format here to say index count and then the letter as well. Okay, so what I'm doing here is at index count, the letter is blank. And then what I will do is say index count plus equals 1. So when I run this, it says back the following information. At index 0, the letter is A. Index 1, letters B, and so on all the way until the end. Now this is such a common operation that what we're going to do is use the enumerate function to replicate this. And the reason this is very common is because a lot of times you will want to have some sort of counter for how many times have you gone through this for loop, or what index position you are at in this particular string. And the reason for that is because often people like to do something like this. They like to, let's define word as A, B, C, D, E, and then say for letter in word, print word at that index count. And then we say index count plus equals 1. So what's actually happening in this loop? Well, we're doing the following. We have an index count starts at 0, and we have a word string A, B, C, D, E. Then for every letter in that word, so for every character here, what we end up doing is we print the index value location at that word. And that's the same thing as printing the letter. But oftentimes what we'll end up doing is using this sort of syntax with a list later on in our code. But in order to do this, we need to have some sort of running index count. So when I run this, I get back A, B, C, D, E. Because this sort of operation is really common later on, what Python did is they built in the enumerate function. So let's see what happens when we use enumerate. So I'm going to delete index count here, and I will say for item in enumerate word, print out the item. And now when I run this, I get back, notice, tuples. So 0 with A, 1 with B, 2 with C. So this is basically doing that index count for us automatically in the form of tuples. And as we know, we have tuple unpacking from the for loop lecture, so I could say the following. I could say index, comma, letter, and then I could print out the index, and then print out the letter separately, and then print out a new line using an escape sequence character. So now I say 0A, 1B, 2C, etc., and so on. So this is the enumerate function, and it can take in any iterable object, and what it does is it returns back some sort of index counter and then the object itself, or the element at that particular iteration. The next one I want to show you is the zip function, which is kind of almost like an opposite of enumerate. What it does is it zips together two lists. So I'll say my list 1 is equal to 1, 2, 3, 4, 5. And I'm going to make my list 2 equal to A, B, C, D. Actually, let's just do A, B, C, 1, 2, 3. That way they match up. And then what I will do here is I will zip them together using the zip function. Now, if I just run zip, I don't get back anything. It just says, hey, you have this zip generator waiting for you at this location in your memory. If we actually iterate through it, so if I say for item in zip my list, and then I print out the item, notice we get back this list of tuples. So previously in that for loop lecture, I mentioned that tuple unpacking is going to be a really useful thing because a lot of built-in functions in Python return back a list of tuples, and this is one such function. The zip function will, just like a zipper on a jacket, zip together these two lists and pair up these items so that they match together. And you can actually do this with more than just two lists. So I could say my list 3, and let's set this equal to some digits here. We'll say 100, 200, 300, and I could pass in this as another thing, my list 3, and now I can see the output is these tuples of 3 items. A common question is what happens if these lists are uneven? Well, we can check that. Let's add in a bunch more elements to the first list. So we're going to say 4, 5, 6 here. Now when we run this, we actually get back the same results. So keep in mind, zip is only going to be able to go and zip together as far as the list, which is the shortest. So it won't give an error, it'll just ignore everything else that's extra. You see here that we iterated through the zip, but if you actually just want to get the list itself, you can just cast it using list. So we can say list of zip, and then we'll put these lists together. And there you go, 1A, 2B, 3C. All right, that's the zip operator, very useful for zipping together two lists if you want to later use them together using tuple unpacking. So as I mentioned, you could unpack these. So I could say A comma B comma C, and maybe just print out B here, and I only get back the letters. Now I want to show you the in operator. We've already seen the in keyword during the for loop, but we can use it to quickly check if an object is in a list. I can say is X in the list 1, 2, 3, and it will return back a Boolean true or false. Is it in 1, 2, 3? I could also use it for a list of letters. So for example, let's now say X, Y, Z. And now it returns true because X is in that list. So this is a really nice way to quickly check if something is in a list. So now let's change this to 2 in 1, 2, 3, and it gets back true. The in keyword, it also works on other iterable object types, so it works in strings as well. You can say is A in a world, and it returns back true. This also works in dictionaries as well for their keys. So I could say my key, and then check if it's in a dictionary. Let's quickly create one that has that key, my key, and let's give it some value, 345, and it returns back true because my key is in this dictionary. If you wanted to check if it's in items or if it's in the values, then you could just call that itself. So to show you what I mean by that, let's get back this dictionary. And then I could say, hey, is 345 in d dot values? It returns back true. If I asked for keys, it returns back false. So that's the in keyword operator, very useful for quickly checking. I like to use it a lot when working with strings. A few more that I want to show you is some mathematical functions, min, max, and then the random library. So if you ever have a string of numbers, let's quickly create one. My list, 10, 20, 30, 40, and let's go jump to 100. If I ever wanted to know the minimum value there, there's a built-in min function that I could pass in, and it reports back the minimum of the list. And there's also a max function that reports back the maximum value of a list. So keep that in mind because often it's going to be very tempting to use min and max as keywords, but they're already built-in functions in Python, so you should not use those. And that's denoted by the fact that they show you syntax highlighting there. Okay, let's quickly discuss the random library. So Python actually comes with its built-in random library, and there's a ton of functions included in this library. And this is actually going to be our first example of importing a library. So to import functions from a library, what you can do is say from random import, and if you hit tab here, you should be able to see a big drop-down list of options, and a lot of these are the functions that are available to you inside this particular built-in library. So the one we're going to show you right now is shuffle. So what this is saying is, hey, from that random library that's built into Python, import the shuffle function. And later on in this course, we'll discuss how to download other libraries from the internet. But for right now, random's built in. So now we have this shuffle function, and what it does is it randomly shuffles around any sort of list. So let's create another list, and let's make it in order. So 3, 4, 5, 6, 7, 8, 9, 10. And if we shuffle this list and then call the list again, it's now shuffled or scrambled. And if we run this shuffle again, so notice here I'm going to run that one more time, it's going to reshuffle the list. You should also note that it's actually not returning anything. So if I asked for this, random list is equal to shuffle, that's not going to work because it's not returning anything. So it's going to just say, hey, there's nothing there. And if you check out the type of this, it again says none type. So this is an in-place function, meaning it operates in place on that list. So if I check out my list, now it's still scrambled. Okay, so that's my list, and that's the shuffle function for shuffling a list. There's also a really nice function for grabbing a random integer. So we can say from random import rand int, and that allows us to quickly grab a random integer. So I will say rand int, and what we do here is we pass in a lower range and a upper range. So I can say rand int from 0 to 100, and it returns back some random integer. And if I do this again, from 0 to 100, another random integer. And most likely your numbers will be different than mine because, again, it's random. And because this is returning something, I can save it. So I can say my num is equal to rand int, 0 to 10, and then I can later on use that number. Finally, let's show you how to accept user input, and it's actually quite easy with the input function. So we use the special keyword input function, and then we have the text that wants to show up when we actually ask the user for input. So I'll say, hey, enter a number here, colon space, and when you run this, now Python's asking you to enter a number. So we'll go ahead and enter one. We'll say 50, and there we go. Now it has 50. Typically what you're going to do is save this as some sort of result. So you'll say, hey, whatever variable you want is equal to input. And this phrase, you can say whatever you want. So we could say, what is your name? We run this, and then it says, what's your name? I'll type in Jose. And then later on in your code, what you can do is refer to result, and we get back Jose as a string. So that's the basics of input. The thing you got to watch out for is that input always accepts anything that's passed into it as a string. So let's go back to that number example. So we'll ask the user, hey, what's your favorite number? When we run that, if I pass in 30 and I hit enter there, and then I ask for the result, it's actually the string version of 30. So if I say type of result here, it says, hey, it's a string. So in order to actually cast this or really transform it into another data type, what I need to do is say either float of result to get back 30.0, or if I still want it to be an integer, I can say integer result and it returns back 30. And now it's an actual number instead of a string, because if you just say result, notice here it still has those quotes. So keep that in mind. Input always accepts things as a string, because later on you may want to be using input for grabbing an index position, so you will most likely have to cast it. And you can do this all in one line by saying wrap this in int, and then we will get a favorite number here. So I say 20, and now when I check the type of my result, it's an integer. Okay, so that's the basics of the input function. And those are some other useful operators that we'll be using, especially later on in your first milestone project. You can check out the notebook for more examples, and I will see you at the next lecture. Thanks, everyone. Welcome back. Before we finish off this section and head over to your assessment test, I want to quickly discuss a concept known as list comprehensions. List comprehensions are a unique way of quickly creating a list with Python. So if you're ever in a situation where you find yourself using a for loop along with an append statement that goes over and over again through a for loop to create a list comprehensions are a good alternative to this method. So to show you what I'm actually talking about, let's jump to a Jupyter Notebook. Okay, let's imagine that we have a string called myString, and we say it's hello. And I want to make a list of every character in this. What you may do is start off with an empty list, such as this, and then say for letter in my string, append the letter to my list. And then after running this, if I check out what my list looks like now, I get back HELLO. So this is something that's really common for beginners to do. They create an empty list, and then they iterate through some other iterable, and then they append whatever object that is or whatever element that is to their list. There's actually a more efficient way to do this in Python, and by efficient, I really mean taking up less space in code. As far as the actual computation, it's about the same, so don't worry about saving computational time using this method. If you find this method too confusing, you can always go back to the for loop. But let me show you how you could do this exact same thing on a single line. What you do is you essentially break down this entire for loop. So I'm going to copy this again here, and then slowly break it down to be in the format of a list comprehension. So first off, all of this code and logic here in some format is actually going to go inside these braces. And we basically reorganize this. We say for letter in my string, we're going to delete all this and then put letter right here. So now we have letter for letter in my string. Cut that, paste it in here, run that, and now we have the exact same thing, HELLO. So what's actually happening here? The logic is essentially a flattened out for loop, because we're going to assume that the only action being taken in this for loop is just appending whatever element you want to your same list. What list comprehension does is it just takes that element for element in some other iterable object, such as another list. So let's show you another example. We can say my list is equal to open and close square brackets, x for x in Word. And then if I check out my list, I get back WORD. And just like a for loop, this is a temporary variable name that you can call whatever you want. So we could call it just QWE, and as long as it matches here, let's make it Word2 so we can see that it's actually working, Word2. So again, it's just element for element in, and then some sort of string, list, or other iterable object. So often what you're going to see is something like this. My list is equal to open and close square braces, and then what I'm going to do here is say x for x in range 0 to 11. So now my list are those actual numbers. So instead of saying x, what I'm going to do is say num, because that's a little clearer to me. So I have this flattened out for loop. Now you may be wondering, well, is this all it can do? And that's actually not all it can do. In fact, you can begin to perform operations on this first variable name. So if I wanted to grab the square of every number in that range, what I could do is perform the operation here. So I'm saying number squared for num in range 0 to 11. So then when I rerun this, now I get back the squared versions of that. So what this is doing is essentially flattening out this for loop right here, where this letter or this number, whatever it happens to be, is basically as if you had done squared here. That's what we're doing when we say squared right here. So you're appending whatever this happens to be. Now you can also add in if statements into this. So let's say we only wanted to grab the even numbers from this. What I could do is say my list is equal to open and close square brackets, and then say x for x in range 0 to 11. And then after this is where you add in the if statement. You can say if x mod 2 is equal to 0. So remember, that's to check if something's even. So I'm saying x for x in this range of numbers, but only if when you say mod 2 of that x, it's equal to 0. And now when I check the result of my list, it's only the even numbers. And I could also do something like this, x to the power of 2 here, and now I only have the square of the even numbers. Now you can do some more complex things, like more complex arithmetic here. So I'm going to show you one last example. Let's imagine we have a list of temperatures in Celsius. So 0, 10, 20, let's say 34.5. And then I wanted them in Fahrenheit. So let's do that. A list called Fahrenheit. I will set that equal to, and then there's some sort of formula for the conversion, and the formula is 9/5 times the temperature in Celsius plus 32. So here I have quite a complex arithmetic arrangement, but then I'm going to say for temp in Celsius. And then when I run that and I see Fahrenheit again, I see back the temperatures in Fahrenheit. So 0 degrees Fahrenheit is 32, or excuse me, 0 degrees Celsius is 32 degrees Fahrenheit. So I'm going to break this down as a for loop just so we can see the connection. This is the exact same thing as me doing the following, as me saying Fahrenheit, set that equal to an empty list, and then say for F-O-R, temp in Celsius, Fahrenheit, append, and then just doing this sort of thing right here. Just grabbing this and putting it in there. So this is the exact same thing, and if I check out Fahrenheit, I get back the same result. So what I would suggest is you basically freeze this video right here and see if you can build out the comparisons between this flattened version for list comprehension and this version for the for loop. Because all we're really doing here is flattening out and getting rid of this append functionality, because it's essentially implied by default when you put it all in this list comprehension. Now often I'm asked by students as they review their list comprehension, hey, am I able to do if-else statements inside of a list comprehension? And the answer to that is yes, you can, but the order is going to be a little different. And before I show you this, I want to emphasize that above all else, readability and reproducibility in your Python code should be the most important thing, not trying to do slick one-liners. And list comprehensions can kind of fool you into thinking you're becoming a really good programmer, when in fact you're writing just kind of really one-liners that are really ugly, and it's hard to read when you come back to them a month later. So keep that in mind. I am going to show you right now how to do it, but I myself typically don't do this because it's really hard to read once you come back to it. But let me show you how to use an if and else statement inside of a list comprehension. So the way we do this is, let's say results. We're going to set that equal to, and the order is a little reversed here. You say x if, and then you have your if statement. So we'll say x if x mod 2 is equal to 0. And then we have our else statement, else do odd. And then we say for x in, and then we can say range 0 to 11. So this is kind of weird because now the order has been totally reversed, different than what I said up here. So that's why I also recommend that you kind of take it easy when you're doing if-else statements in a list comprehension, because it can quickly become unreadable or confusing because the order is different. But when you run this and we check out our results, now I have a list where I have the even numbers, or basically the numbers where you mod 2 is equal to 0, and then the string odd if that's not the case. So that's, you can use if-else in a list comprehension. Notice how the order is now different than just a simple if statement inside of a list comprehension. Also keep in mind that a month later when you're coming back to this, it's definitely going to take a little longer to read and understand what you were doing here. So be kind to your future self. One last note I want to show is you can also do nested loops in a list comprehension. This is going to be another topic where I would say take it easy at first because it can become quite confusing. But let me show you what I mean by a nested loop. We haven't actually seen a nested loop yet, so we'll introduce one first. Let's imagine I have my list as an empty list there, and I say for x in, and let's say 246. And then inside of this, I'm going to make another for loop. We'll say for y in, and let's say 100, 200, 300. I'm going to take my list, and I'm going to append x times y. So I run that, and then outside of those for loops, I print out my list, and I get back 200, 400, 600, etc., all the way to the end. So what is this actually doing? Well, it's going to take 2, multiply it by each of these numbers. Then it's going to take 4, multiply it by each of those numbers, resulting in this. And then it's going to take 6, multiply it by each of those numbers, and then result in that. So let me choose a couple numbers here that will make it even more obvious what's happening. I'm going to say 1, 10, and then we'll make this last one 1,000. So when I rerun this code, you can see here 2, 22,000, 4, 44,000, 6, 60, 60,000. Now, there is a way to do this with list comprehension. Again, you're going to sacrifice readability here, but it is possible. The way you would do this is the following manner. We would say my list is equal to, and then we say x times y for x in, and then you pass in that list. So in this case, we're going to say 246, and then we'll say for y in, and then here we'll say 110, 1000. And when we check out my list, we get back the same result. Now again, definitely be careful with this because this is really hard to read, especially when you're coming back to it later. So it's possible, but I would suggest always try to do readability first. Okay, that's the basics of list comprehension. We'll play around with them a little bit in some of your exercises and projects, but it'll definitely take a while before this becomes part of your normal flow in programming of Python. All right, thanks everyone, and I'll see you at the next lecture. Welcome back everyone. Let's finish up this section by having your statements assessment test. I'm going to quickly go over the notebook in this lecture, and then in the very next lecture, we'll go over the solutions. Let's head over to the notebook. All right, here I am at the GitHub repo for this course, and in order to find the notebook that I'm referring to, it's going to be under Python statements, and then come down to statements assessment test. There's also a solutions notebook, which we're going to go over in the very next lecture. Click on statements assessment test, and then let me quickly go over the questions. So for this one, we want you to use a for statement, the dot split method off a string, see if you remember that one, and an if statement to create a statement that's going to print out the words that start with an S. So here I've given you a string, and I want you to use a for loop along with split and if that's going to be able to print out only the words in this string that start with an S. Then I want you to use range to print out all the even numbers from 0 to 10. Then I want you to use list comprehension to create a list of all numbers between 1 and 50 that are divisible by 3. And that's to be evenly divisible by 3, so let me just clarify that. And then I want you to go through the string below, and if the length of a word is even, print even. So this one's a little more complex than what we've seen in these earlier questions. So what we're going to do is use what you know about Python statements, maybe a for loop here, to go through the string and every single word, so remember you're going to have to use some sort of split on the white space, and then if the length of the word is even, print out even. Next, I want you to write a program that prints the integers from 1 to 100, but for multiples of 3, print out fizz instead of the number, and for multiples of 5, print out buzz. And for numbers which are multiples of both 3 and 5, print out fizzbuzz. So this is a very common question, and it's kind of used as a base filter for some interviewers when they want to know, does this person even really know how to program? So this is a really famous question called fizzbuzz. And then finally, I want you to use list comprehension to create a list of the first letters of every word in the string below. So again, we have a string below, use list comprehension to create a list of the first letters of every single word. Okay, best of luck, and definitely a big hint here is utilizing dot split. You're going to need to use that for a lot of these test questions. We'll see you at the next lecture where we go over the solutions. Welcome back. In this lecture, we're going to go over the solutions for the test shown in the previous lecture. Let's get started by opening up a Jupyter Notebook. Okay, let's get started with our statements assessment test solutions. The first question wanted us to create a statement that will print out words that start with an S from this string right here. So let's run this cell. So now we have our string defined. So there's our string, and we can use the dot split statement, if you recall from the strings lecture, to create a list. And dot split by default splits on the white space, so now we have all the words right here. So let's use a for loop to iterate through this. I can say for word in stsplit, and if I just print out the word, I get back the words themselves. But what I want to do is create some sort of if statement that checks if the word starts with an S. So how do I do that? Well, I can actually grab the first letter of the word using indexing. Because these are all strings, I can say word of 0 at index 0, that's the first letter. So I can say if word at index 0, the first letter, is equal to the string S, print word. And there we go, we have start, S, and sentence. Something else I wanted to note here is let's imagine that there was a word here that started with a capital S. So if I say Sam, print only the words that start with an S. If I run this, this actually no longer works because it's missing out this capital S. What I could do is force this letter to be lowercase when I do the comparison in order to compare to this lowercase s. So there's two ways I could do this. I could say if word 0 when it's lowercase is equal to lowercase s, and then I do grab Sam right here. So that's one way I could do that. The other way I could do that is just compare both a lowercase s and a capital S. I could say if word is equal to s right here, so if this first letter is equal to lowercase s, or word 0 is equal to capital S. And then that's the exact same thing. Typically what you're going to see from a more experienced Python programmer is the call of lower instead of or, because it's less code and it looks a little cleaner. So that's a way you could deal with capital S's if they happen to be in that string. To keep it simple, we didn't have that, but just keep that in mind. Up next, we wanted you to use range to print out all the even numbers from 0 to 10. So that's pretty straightforward. And there's lots of ways you could have done this. You could have just said list range 0, 11, 2, and there we have all the numbers. But if we actually wanted you to print them, you could have said for num in range 0, 11, 12, print out num, and we would have accepted that as well. So either one of these is fine. Main thing I want you to realize is that range, you'd have to say up to 11 if you want to go to 10. And then we have to have 2 as the step size. Next, we want you to use a list comprehension to create a list of all numbers between 1 and 50 that are divisible by 3. So the way we can do that is the following. We'll say x for x in range, and we'll go from 1 up to 51 because we want to go up to 50. So we'll go up to, but not including 51. And then we can say if x mod 3 is equal to 0. So we run that and we get back these results. And this was really similar to other examples we saw when we were printing out all the even numbers. Here we're just checking if they're divisible by 3 instead. Evenly divisible, that is. Next question was to go through the string below, and if the length of a word is even, print even. So let's do that. It's going to be very similar to the first question. We'll say for word in st split, except now the if statement is going to check the length of the word. We're going to say if the length of the word when divided by 2 has a remainder of 0, I will print out the word. Or I will print out even. Doesn't really matter what you do here. We can say print is even, so I'm just using some string concatenation there. So only is even, that is even, with even, etc. So there you have it. The next question is a really common question called FizzBuzz. And that's where we have to write a program that prints out the integers from 1 to 100, except we're going to replace integers with words when they're multiples of 3, multiples of 5, or if they're multiples of both 3 and 5. And there's a bit of a trick to this one, but first let's figure out how to actually print the numbers. We're going to say for num in range 1 to 101, because that actually gives us back all the way to 100. And the first thing we need to check is multiples of both 3 and 5. Often, what beginners will do is they'll make the mistake of checking for 3 first, then checking for 5, and then checking for 3 and 5. But the problem with that is multiples of both 3 and 5 are technically also a multiple of 3. So you accidentally end up printing out fizz when you should be printing out FizzBuzz. So the very first thing you need to check for, logically, is 3 and 5 with FizzBuzz. So we will say if num mod 3 is equal to 0 and num mod 5 is equal to 0, we will print out FizzBuzz. Then we can check for the other cases. So we can say elif num mod 3 is equal to 0, print out fizz, and then we could say elif num mod 5 is equal to 0, print out buzz. Else, remember we want to print the integers, so else we'll just print out the integer. Print the number itself. So when you run this, you get back 1, 2, fizz, 4, buzz, fizz, and if you keep going all the way to 15, finally you get FizzBuzz. So the main trick here is to check for 3 and 5 first. That way you don't accidentally trigger one of these by accident. Then moving on to the next question, we wanted to use list comprehension to create a list of the first letters of every word in the string below. And to do this, it's going to be a bit similar to what we did before. We say word for word in st.split, but I just want to grab the actual first letter. So if I were to run this, it would bring me back all the words. I just want the first letter. So here I index for 0. And when I run that, I get back the first letter for every word in the string. Okay, that's it. Take some time to review these. A lot of these are kind of tricky and you have to wrap your head around them at first, but hopefully with this solution review, you kind of start getting the idea of applying and mixing the ideas that we've just talked about together to solve real problems. Coming up next, we're going to go to the next section where we're going to begin understanding things like functions. I'll see you there.